Okay, so here's this Delaunay triangulation that we had, and then here's the histogram of the connection. So here on average it looks like there's 6 connections.
Yeah.
And then, so what do you think it's going to look like here with this sort of graph? With the same parameters, you were infected for 8 days, and different meetings per step.
I think this one spread pretty fast than our other models. I think we'll have a higher peak early on, maybe a higher peak like generally in here, but I think we'll see the same graphs for the total is just going to go up after a point.
Maybe around point like 1.6. That's if you have connections with 6 people, then if you have a 1/6 chance to infect someone, you're going to infect 1 person every step on average.
Uh-huh.
So maybe that point where it just jumps really fast will be around 0.16.
Okay, interesting. Let's see.
No, it's still very low.
So very low.
I mean, too. Interesting that this, I don't know if it doesn't seem to be going as high. Or maybe it's just wider overall, I can't tell for sure.
Okay, well let's go down and take a look. So here's this graph. Just make sure I'm on screen. All right, so here's the spread again. Now you thought it would start earlier, but it doesn't seem to have.
No.
Mm-hmm. Seems pretty much identical to the 3D graph one. Maybe in both regards. You still have your critical point, and then this goes up slowly.
Okay, what do you think?
I actually think the critical point happened just a little later.
Oh, a little later even.
Than the grid just happened.
Yeah, it's hard to tell. It looks like it's always in between 0.2 and 0.4.
Yeah.
But I don't know exactly when it happens. We would have to run, I think, more simulations to really identify where that jump was happening. But it's certainly in between 0.2 and 0.4. Okay, so let's go to the more complicated graphs now. We got 3 of those.
All right.